Hello, in this video, we will talk about integration of STEM disciplines and computational thinking. Each of the disciplines that comprise the abbreviation STEM was mentioned in previous videos. In STEM education, there is an interaction between more than one of the disciplines of science, technology, engineering, and mathematics, sometimes at the same time. The interaction between four disciplines in STEM is sometimes emphasized with the term iSTEM. Coherence between the different disciplines is central here. In STEM education, four subjects are treated as a single subject in which skills are acquired in a unified way, and the connection between them are evident. In this way, STEM education builds a STEM literacy that enables children and young people to understand and apply insights and practices of the different STEM disciplines. Children develop and practice these insights and practices by using them to solve problems or challenges that are meaningful to them. Consequently, children and young people also become aware of the interaction between STEM and society, which is an important element of STEM literacy. STEM stands for integration, but that integration cannot simply be captured in one didactic model or a single defined activity. For example, various grouping forms are possible. Children can work individually, in small groups, or together with all children to solve a problem. During a STEM activity, different grouping forms are often alternated. Not only organizationally, but also in content, STEM cannot be reduced to one well-defined model. A particular discipline may be addressed to a greater or lesser extent in a STEM activity. As described in previous topics, STEM education does not only boost children's STEM literacy, because STEM is characterized by a didactic approach in which problem-centered learning is central. STEM primarily gives children also the opportunity to develop 21st century competencies. In STEM education, children solve problems through skillful and creative inquiry and design, but also through communication and collaboration. Computational thinking can be described as the human ability to solve complex problems, viewing computers as helpful tools. At the same time, it focuses on people's ways of solving problems rather than encouraging them to think like computers. Computational thinking is also present in problem solving, communication, and interaction with other people. Computational skills should enable children and adults to explore and solve problems in such a way that computers can solve them. In this way, they bear many similarities in inquiry and design skills, but they also have their own emphases to help preschoolers grow into creative problem solvers. Computational thinking can be seen as a pivotal competence for people to live in the 21st century, where people understand a problem and formulate a solution. Computational thinking includes several skills. These skills can be applied by children during STEM projects to facilitate their problem-solving process. STEM and computational thinking are often found together in so-called plugged activities, but also unplugged activities, means no use of digital tools are possible. That unplugged method is appropriate to stimulate the problem-solving ability of preschoolers. We must not lose sight of the fact that a lot of skills from computational thinking are already being used in the kindergarten class. For example, when we let the children repeat a task in their own words, or when they follow a recipe step by step.